All right, 5.2 properties of logarithms. So the first thing that we need to talk about is how you can rewrite a log from an exponential function. So on this right-hand side over here, we have b raised to the power of p equals x. So the base of your logarithm becomes the base of your log. What your exponential function is raised to, so the power it's raised to, is what your logarithm is going to equal. And then what your exponential function equals is what you're taking your log of. So another way you can think of it, because on this assignment you're going to have to change them from log form to exponential form. You take your base of your logarithm, becomes the base for your exponent. You raise it to the power of what your logarithm equals, which in our case is p. And then that's going to equal what you're taking the log of, which is x. So that's how you rewrite it. All right, the next thing we need to talk about is two terms that you need to know. If you have log of x, that means that you're going to have a log of base 10. So if you have a log written where the base is not written, it's understood as a 10. The other one you need to learn is a natural log, which is this lowercase l in x, and that one has a base of e. So in order to get that to cancel out, you have to use an e. All right, let's talk about the different properties you're going to need to know. So let's talk about all these exponential properties over on the left first. So 10 to the 0 power equals 1. Anything raised to the 0 power is going to equal 1. So any number, a million, it could be a -2, anything raised to the 0 power is going to be 1. Remember, when you have 10 to the a power times 10 to the b power, you're going to add your exponents together. If you have 10 to the c power divided by 10 to the d power, you subtract your exponents. If you have 10 to the x power raised to the y power, so a power raised to a power, you multiply the exponents. And then these are two that we're going to use a lot on this assignment. This states that if you have 1 over a to the k power, you can move it out of a fraction by flipping the sign on the exponent. So you make it a to the -k power. Another example of this is if you have like a to the -2 power. That would equal 1 over a squared. Or if you need to move it, if it's already a negative in the denominator, so let's do like this. I'm going to write over here on the left. If you have 1 over, or b over c to the -2 power, let's say, if you want to move that c to the numerator, it'd be b times c to the +2 power. So switching just the sign on the exponent will make it move to the top of the fraction. All right, if you have this kth root of a, that equals 1 over k. So another example of this would be like if we have the cube root of x, it's understood that the x is to the first power, so that would equal x to the 1/3 power. Another example of this is if you had the fifth root of x squared. You can rewrite that as x to the 2/5 power. So those are going to be two of the ones we use a lot. So how do logarithms compare to this? So if we are looking at the first two up here where it was 10 to the 0 equals 1 and we have log of 1 equals 0. Remember, if it's just a log, the base is a 10. So if I rewrote this in exponential form, which was the first thing we talked about, you would say it's 10 raised to the power of 0 equals what we're taking the log of, which is 1, which matches our first statement over there. The same thing happens over here on the natural log. If you have a natural log, it's understood the base is an e, so you would say it's e to the 0 power. That also equals 1. Again, any value raised to the 0 power is 1. When we did our exponential functions over here on the left, we said that 10 to the a times 10 to the b, we added our exponents together. So if we're multiplying logarithms, so we have log of a times b, you can change your logarithm to addition. You can also go vice versa. If you have two logs that are added together, you can change that back to multiplication. If you have 10 to the c divided by 10 to the 10 to the c divided by 10 to the d power, you subtract your exponents. Okay, so if you look over here at this logarithm, if you're doing division, c of c divided by d, this is hard to say, then you subtract your exponents, and vice versa. If you have subtraction, you know you can change it to division. If you have 10 to the x raised to the y power, we multiplied our exponents. So over here we have log of x raised to the y power. So if you do that, you're going to take your exponent and you're going to move it to the front, and you're going to multiply those two things together. Alright, this next one is kind of different. So this one we have log of 10 raised to the x power. So it's understood that that base is a 10. Your exponent from the previous one we just talked about moves to the front. So we have x times log base 10 of 10. If your base of your logarithm matches the base for your exponent, which was 10, this just cancels out, and that's why it just equals x up here at the top, right there. Alright, same thing right here. Log base b of b, so the base of our log matches the base of our exponent. We know that's going to cancel, so that's just going to equal p because that's the only thing left. Same thing happens here. We have 10 raised to the power of log base 10 of x. Again, the base of our exponent matches the base of our log, so they cancel, and we're just left with the x. Same thing down here. B raised to the power of log base b of x. The base of our exponent matches the base of our log. They cancel, so it's just x. The same thing applies over here on natural logs, so I'm not going to go through all of these, but just remember that if it's a natural log, I'm going to look at this one. It's a natural log of e to the x. Remember that natural log has a base of e. So that e and that e to the and the e and the e to the x would cancel out, and you would just be left with the x. Same thing here. An e and a natural log cancel each other out. Alright, so now that I've gone through all the properties, let's go through and do some of these problems. So number one says evaluate log base 11 of 11 to the 42nd power. So notice the base of your log matches the base of your exponent, so it cancels. That's 42. Go to the next one. We have log of 10 to the 31st power. So your base here is understood to be a 10 because it says log, so that these cancel, and the only thing left is 31. Let's go to the next one. 8 raised to the power of log base 8 of 423. The base of our exponent matches the base of our log, cancel, so it's 423. Let's go to number 4. We have e raised to the natural log of e, or natural log of 53. So remember, a natural log has a base of e, so these e's would cancel out, so we're just left with a 53. This next one says the natural log of 1 over e to the negative 12th power. So I could rewrite this as the natural log. I can't cancel this since it's in the bottom of a fraction. You can't do that. So in order to cancel it, I need to move that e to the negative 12th power to the top of the fraction. And if you remember, we talked about this at the beginning. You just flip the sign on the exponent. So it becomes e to the positive 12th power. E and a natural log cancel each other out, so this just equals 12. Alright, 6 is going to change a little bit. So this one we have log base 7 of 49. What we're going to try to do is we're going to try to make our bases match. So I'm going to rewrite this as log base 7 of 7 squared, because 7 squared is 49. Now that our bases match, we can cancel it, and our answer is 2. Let's do the same thing on the next one. We have log base 6 of 216. So you need to go through and think, well, I need to get my bases to be the same. So go through and think about what 6 to what power gets us 216. So I'll give you a second to either try to do that on your calculator, or maybe you know it off the top of your head. Hopefully you got 6 to the 3rd. Oops, I wrote that wrong. 6 to the 3rd. So now that our bases match, they cancel, and we just get 3. The next one says log base 3 of 243. So you're going to get the bases to match. So you're going to say log base 3 of 3 to what power is 243? So how many 3's do I have to multiply together to get 243? That's 5. So these cancel, and your answer is just 5. All right, down here at the bottom, it says evaluate log base 3 of 1 over 81. So we're going to do the same thing. We're going to say log base 3 of 3. So we have to first think, 3 to what power is 81? Well, that would be 4. And to move it to the bottom of a fraction, our exponent has to be a negative. So those cancel. So my answer is negative 4. All right, number 10 says rewrite in exponential form and then solve for x. So if we're writing it in exponential form, that's where we do our little loop around. So we start with our base. Our base is 5. We raise it to the power of what it equals, so 5 to the third equals what we're taking the log of, which is x. So 5 to the third is 125. Let's go to the back. This one says the same thing, rewrite in exponential form and then solve for x. So start again with your base. So your base is 2 raised to the power of x. And that's going to equal 16. So how many 2's do we have to multiply together to get 16? That would be 4. Let's go to the next one. Same instructions. So we're going to do x to the second power equals 121. So what squared gives us 121? That would be 11. This one, rewrite in exponential form, solve for x. So it just says log of x. So it's understood the base is a 10. So you're going to say 10 to the power of 6 equals what we're taking the log of, which is x. And x would equal, and all your exponent does is tell you how many zeros you have. So you have 6 zeros. So it would be 1,000,000. All right, same concept here. Log of 10 million equals x, so make your base 10. We have 10 raised to the x power equals 10 million. And again, if you want to figure this out really fast, you just count your zeros, so x equals 7. Rewrite this one. So we have 8 raised to the power of 0 equals x. Anything raised to the 0 power is 1. Let's go to the next one. We have natural log of 1 equals x. So remember your base is understood to be an e. So it's e to the power of x equals 1. Anything raised to this power gives us a 1, so x equals 0. If you type that in on Canvas, it's going to say it's an unanswered question, but it will grade the 0. There's just some sort of glitch in Canvas that says you didn't answer it. All right, this one we're doing the same thing. So we're going to start with 2 raised to the power of x equals 1 over 64. So you should look at this right away and know that x is going to equal a negative number because it becomes a fraction. And then 2 to what power would get us 64? And that would be 6. You would have to multiply 6 2's together to get 64. All right, this next one, rewrite it. So it'd be x to the 4/3 equals 16. So if we want to solve for x, we need to move that 4/3 exponent to the other side. And in order to do that, all you have to do is flip the fraction. Instead of 4/3, make it 3/4. And then you can just type that in your calculator. And if you do that, you're going to get x equals 8. All right, number 19 says evaluate log base 3 of the 5th root of 27. So first, let's start out with log base 3 of 27. And if it's a 5th root, we talked about this on the front, that means it's going to be raised to it's like there's a 1 right there. So it's going to be raised to the 1/5 power. All right, I'm going to go through and I'm going to try to make a base that matches that 3 so that we can cancel it out because 3 goes into 27. So I'm going to rewrite this as log base 3 of 3 to the 3rd because 3 to the 3rd is 27. But then I still have that 1/5 on the outside, so times 1 or raised to the 1/5 power. When you do that, remember an exponent raised to another exponent, you have to multiply these two things together. So this becomes log base 3 of 3 to the 3/5 power. Now that we have a log base 3 of 3, these cancel, so our answer is 3/5. All right, this next one says express the logarithm in terms of the natural log of 2 and the natural log of 5. So I need to break my 32, because it says natural log of 32 over 25. I need to break my 32 down to include 2's, and I need to break my 125 down into 5's. So if I do that, that would be the natural log, and 2 to what power is 32, and that would be 5. And then 5 to what power is 125? That would be 3. All right, we're going to go back to use this property now on the front. We're going to go to this because we know that division can change to subtraction. So we're going to do that. So that becomes the natural log. And when you expand it and you make it subtraction, you have to put a natural log with each piece of it. So it'd be natural log of 2 to the 5th minus the natural log of 5 to the 3rd. And then we talked about this at the beginning. Exponents move to the front of the log that they're with. So this would be 5 natural log of 2 minus 3 natural log of 5. And that would be your answer. All right, last two, I mean. So this one says expand. Log base 7 of 4x to the 3rd over x plus 1 to the 6th. So we're going to start with log base 7. I'm going to make this a little more obvious. This would be 4 times x to the 3rd over x plus 1 to the 6th. Okay, first thing we're going to do is we're going to work with this multiplication. And we talked about earlier that multiplication changes to addition. So we're going to have log base 7 of 4 plus, and if we're expanding it, we have to write the log with each piece, log base 7 of x to the 3rd, and then division changes to subtraction, and you have to write the log with it because you're expanding it, of x plus 1 to the 6th. And then we talked about exponents move to the front of the log that they're with. So our answer would be log base 7 of 4 plus 3 log base 7 of x minus 6 log base 7 of x plus 1. And you're not going to break that x plus 1 up because it's in parentheses. All right, for this next one, it wants us to condense. So it basically wants us to work backwards from what we did on the previous one. So I'm just going to rewrite this out so I can write and it's not going to mix into the problem above. So the numbers in front of the logs are going to move back and become exponents for those values. So we have natural log of 15 minus natural log of a plus 1 squared plus natural log of b to the 4th. Now we're going to do our addition and subtraction stuff. So when you condense, you just write natural log once. Our first term is 15, so we're going to have a 15 up here. Minus means division. We're going to put the a plus 1 in the denominator. And then plus the natural log of b to the 4th. So if it's plus, it's like multiplication. So multiplying by b to the 4th. Well, we have to figure out that b to the 4th is going to go in the numerator or the denominator. So that b to the 4th is like over 1. So anytime you're adding, you're going to put everything in the numerator. Whatever is subtracting goes in the denominator. So your final answer would be natural log of 15 b to the 4th over a plus 1 squared. So again, your rule of thumb is if you're adding and you're trying to condense this, everything that's being added goes in the numerator, everything that's being subtracted goes in the denominator. All right, if that was too quick or there wasn't anything you didn't understand, make sure you stop and talk to your teacher and ask questions, and good luck on your assignment.